Okay, because I can't export long videos with Clipchamp, me accidentally turning off the recording is gonna make that a separate recording. Anyways, I forgot to turn off window capture. Let's just let me get this wrong on purpose. Hold on. Actually, wait, no, getting it wrong on purpose. How do I restart? Is it backspace? That's pretty crazy. Hold on, I'm not gonna calculate these. I'm not gonna calculate these. I gotta. No, you know what? Let's level editor this. It's not like I'm doing this like for real, anyways. So I did get this correct. Yeah, let's do here. Why does it still count it as wrong? Dude, just spawn me. Okay, whatever. Anyways, this is a lot easier than the geometry section, by the way. Hold on, let me just get the coins. It's just factoring because when you evaluate the limit, it's indeterminate. I can't explain that in time. I can't explain that in time. Let's try again. When you evaluate the limit directly, aka, or like with direct substitution, you get 0 over 0, which is indeterminate, which means it can have a lot of different values. Which means yeah, you can solve for it, but it's not directly a value. You can only solve for it because it's a limit, which means it's just a value that it's approaching. When you factor x squared minus 4 via... okay, I can't... Still can't explain fast enough. When you factor x squared minus 4 via difference of squares, difference of squares is just if you have x squared minus y squared, the factoring is x minus y, that whole thing in parentheses, times x plus y, that whole thing in parentheses as well. And then you factor out the, because you have x squared minus 4, which means y is 2, and x is still just x. So you have x minus 2x plus 2, you cancel out the x minus, whoops. You cancel out the x minus 2 on the, forgetting to play the game here. You cancel out the x minus 2 on the numerator and denominator, and you're left with x plus 2, which you can evaluate directly. You can evaluate directly. You have to keep in mind that is only for the limit. You can't actually change the function. The actual function evaluation would look like a hole because it's a or it's a removable discontinuity. Okay. The derivative, oh god. Oh god. 10, I can't calculate this in time. Fuck that. Okay, derivative of 2, so collect no coins. Because taking the derivative... See, it's like I want to play this, but I also want to explain it, because... I can't even do some of these in time. What do you mean? What do you mean? I'm just gonna let you guys, like, watch this shit. Even though no one's really watching this, but what do you mean I'm just gonna let you guys watch this without an explanation? Like, no. I'm either explaining a question or I'm ending the video. If I don't understand it, I'm ending the video and maybe I'll figure it out off video. But yeah, so the derivative of f of x here is a constant, which means the derivative of it is always just 0, which means the derivative of it at x equals 2 is still just 0. The derivative of 5x plus 3, the derivative of 3 is 0. The derivative of a sum is the derivative of the different terms you're summing. So, and the derivative of a linear term 5x. Because of power rule. Again, I'm explaining this. Y'all will have to keep up with the disjointed explanations, but yeah. So far we have derivative of a constant is 0, which explains the 10,000 and the 3 in the second one, g of x. And yeah, and we have the derivative of a sum is the derivative of the terms. And because of power rule, x to the power of n equals n times x to the power of n minus 1. And x to the power of 1 means it's going to be n, which is 1, times x to the power of n times x to the power of n minus 1, which is going to be 0. X to the power of 0, which means it's just going to be 1 times 1 times 1, which is just 1. Ultrakill gaming channel explaining calculus very badly because it's disjointed. Actually, I could slow this down. Let's see. Pitch 25%. 10%. No, 20%. Yeah. Let's do that. And then let's here. Oh god. Okay, it looks like we can. You know what? Okay, let me just be smarter about it and screenshot it. Well, no, I can't pause it anyways, so it's like, you know. But yeah. So collect no coins. I need to collect, hold on. The derivative of 5x is 5 because the derivative of a constant times a function is just the derivative of the function. So the derivative of 5x is the same thing as 5 times the derivative of x. The derivative of x, as I explained a while ago, is 1. So that means you have to collect 5 stars, which I can't because... How are you supposed to do these? Again, I think you're expected to pause, right? Like... Like, I'm good enough to slightly retain this information over since a few years ago, but I'm not like... I'm not that good that I can mentally do it in like 30 seconds. Okay, collect 5 stars. The derivative of 10x squared, which is 10x squared plus 15x. 10x squared plus 15x. That's 20x. 20x plus 15. 15 minus 10, which is 5. So I have to collect 5 hearts. Whoops. Okay, so far, it's a lot more important. Also, yeah, that's the main thing. It's just a lot more important I get these right than I get these on time. I yield to the fact that I can't get these in time, dude. Like, that's just a fact. Yes, I cannot get this in 20. I mean, this one I got quickly because this is just basic. That's just basic if you know how to do it. But yeah, these are, yeah. Okay, so... I might be stupid. Hold on. A fifth of... Okay, no, I'm stupid. Right. Since it says 0.2 times the derivative of 6. Since it says the derivative of 6 for g of x, the blue one, one on the middle left-ish. Yeah. The derivative of g of x is again 5, but that's times 1. So, okay, so... Yeah, I realized something was wrong when there was only, Hold on, I still have to avoid the stuff. Okay, there we go. That's 5 hearts and 1 star. Again, it's a lot more important to me that I get these right than I get these on time. Holy shit, dude. The integral of 1 over x squared dx is negative 1 over x. Negative 1 over x plus c. See, I can't get this in time. Like, it's actually impossible. You genuinely have to be a big brain if you have to get all of these in time. I would like it if it was just based on if you collected the right amount, but I guess that could also make it way too easy to guess the right amount. Okay, hold on. Okay, hold on. 1 over x, negative 1 over x plus c. Hold on, I need to see the second part. Negative 1 over x, and then negative 1 over x, which means x is negative, hold on. Yeah, 1. Let me screenshot this. Okay, we're going back to the thing, and let me actually. Why am I even doing this when no one's gonna watch this? Well, I like doing math. Said no one ever except me. Okay, let's see if I can explain this before I have to end the video. Okay. Yeah. Integrating is just the reverse of differentiating, which means. Okay. I'm just gonna skip all that. The derivative of. I do not have brush selected. The derivative of, and I can't see that, and now we have to make it white. The derivative of 1 over x, the derivative, that, yeah. The derivative of 1 over x equals negative 1 over x squared. Now, because we're integrating x to the power of negative 2, which, if you remember your exponent rules, the negative means you have to take the reciprocal, which means you have 1 over. Yeah, instead of, because if you have x squared, which is x times x, if you divide x squared by x, you get x, which is, and the whole concept, that whole concept, like, let's say you have x cubed, you divide by x squared, you have x times x over x times x. You cancel out 2 pairs of x's, and you're left with 1x. And the concept for the exponential rule of division or whatever is just, if you're dividing a variable by itself, you just subtract the power or the exponent of the variable on top. You just subtract it by the exponent of the variable on the bottom. So 3 minus 2, and then you get x to the power of 1, which is just x. And then that same concept can be used to extend. If you have x over x, they're both to the power of 1, which means when you apply that rule, you get 1 minus 1, which is 0. So x to the power of 0 is equal to this. But because these terms are equal, they cancel out, which means that's just 1 over 1, or 1, which means x to the power of 0 equals 1. And the same property, using the same property, if you have a smaller number being divided, or like a smaller exponent on the x in the numerator compared to in the denominator, the result is x to the power of 1 minus 3, which is x to the power of negative 2. And once this cancels out, you're left with 1 over x squared. And that's where the concept of, if you raise something to a negative exponent, it's the same as raising it to the positive version of the exponent and taking the reciprocal. Okay. You can also just use power rule. The power rule subtracts by 1, so you would have x to the power of negative 1. You have n times x to the power of n minus 1, which means you have negative 1, which can just be the negative, times x to the power of n minus 1. N is negative 1, so this becomes negative 2, which, again, that looks very similar to this. I will have to end the video. Oh my god. Looks very similar to this, which means, and just like you can take the constant out when you're differentiating or taking the derivative, you can take the constant out when you are integrating, which means we can take this negative 1 out and just integrate this. But, integrating it reverses it to become this. but we factor the negative out, which means it would actually, yeah. When we integrate it, it actually becomes negative x, power of negative 1. Or when we integrate it, it becomes negative x to the power of negative 1. Because, oh my god, dude, I'm so tired of talking. Hold on. Oh my god, I'm still going. Oh my god, dude.